You may remember that when you have a radical and you can split the radicand up into factors, then you can separate them off and give them their own radical. And what I mean by that is, if you have an A, I have under the radical, I have 81 and x to the 12th. Well, what I could do is I could separate, that's a product, I could separate these off from each other and give them their own radical sign. So if I wanted to simplify the fourth root of 81 to the 12th, I could just look at these separate pieces for my answer. So I know that the fourth root of 81, if I think about that, that's the number multiplied by itself 4 times, I get 81, that's 3. If I look at that next part, the fourth root of x to the 12th, I know that this is the same as saying x to the 12 fourths. And x to the 12 fourths is just the same as x to the third. Now technically, this 3 could have been plus or minus 3 because I'm taking a fourth root of a positive number. So just to be safe, we might want to put a plus and a minus out in front and just to indicate it could be a positive, it could be a negative. Now we're going to go ahead and skip example B because it really is the same type of problem. Now let's look at example C. So we'll just write, we'll skip next to this one. We're going to skip this. Example C, we have 2 cube roots that we're multiplying. Well, probably our best bet from the start, if we looked at these and they're not really easy to simplify separately, is to multiply them together and then look at the product. So if I multiply these two together, I can write that as the cube root of, well, x to the 7th times x to the 2nd is x to the 9th power. So what this is really saying is x to the 9 thirds, or x cubed. So I can multiply radicals as long as they're like radicals, and as long as they have the same index there. Okay, taking a look at example B, there's really 2 approaches. It all sort of depends on what the expectation is in terms of the final answer. When I think about this, the 5th root of x to the 7th, I know that that's the same as saying x to the 7/5. But what if you were not allowed to write fractional exponents? Let's say we wanted to only have integer exponents. If that were the case, we kind of think about this like simplifying radicals that maybe are not perfect squares or perfect cubed or whatever. So if we kind of thought about taking the 5th root of this x to the 7th, but if we thought about it instead of x to the 7th, we thought about it as x to the 5th times x squared, which is really the same thing. I'm just splitting it up so that one of these exponents is a perfect 5th root, because it's, you know, if you raise x to the 5/5, it just turns out to be x to the 1st. So then I could kind of split them off and give them their own radical and then deal with the one that I can actually simplify. So I could take this part, which is the 5th root of x to the 5th, and that just cancels out, it's x to the 5/5, which is x to the 1st, or x, and then I could just leave the part that I couldn't simplify under the radical. So that's what my final answer would look like, x times the 5th root of x to the 2nd power. So with that same thing in mind, when we used to simplify square roots, if they weren't perfect squares, well, what about if we wanted to simplify a cube root? We know that, well, you may not know, but 250 is not a perfect cube. But if we wanted to simplify this, we could think about if there's a perfect cube that is a factor of 250. And I know just a few perfect cubes I kind of keep stored in my brain, and one of them is 125. So I know that 125 goes into 250 2 times. So I could rewrite this as the cube root of 125 times 2. Well, then I could split them off and give them each their own cube root, own radical. And now I could go ahead and take care of the part that is the perfect cube. I know that the cube root of 125 is 5. So I could just write this as 5 times the cube root of 2. And that would be considered simplified. And then this final example, F. Well, you may remember back when we were looking at, you know, say, for instance, with trig ratios, when we had some of the exact values and we had a radical on the denominator. And we said, well, that's not okay to have a radical in the denominator. And so we would multiply the top and the bottom of the fraction by whatever that radical was to kind of cancel it out of the denominator. Well, so in this case, same thing. I've got 3 over the 4th root of x. Well, it's not okay to have that radical on the bottom. But in order to cancel out a 4th root of x, like when we want to cancel out a square root, say we had something like this, 1 over the square root of 2, let's say. We would have to multiply by a square root of 2, and that's because then that gives us 2 of these to pair up, and that ends up making the bottom really the square root of 2 squared. And so we needed a partner to go with it so that we had 2 of them, so it was squared. Well, if you think about that, if we look at this radical, we have a 4th root of x. Okay, if we only multiply by a 4th root of x, another 4th root of x on the bottom, then we have the 4th root of x squared. Well, that squared isn't going to cancel out the 4th root, so we actually have to do this 4 times. And we'd have to do another one, 4th root of x, and then another one, a 4th root of x. And so we'd have to do that same thing on the top. So essentially what we're doing is we're just making sure that we have 4 total 4th roots of x on the bottom so that they cancel out. Well, that would be the same as just doing this. Multiplying by the 4th root of x cubed. And then you could do the exact same thing on the top. You could multiply by the 4th root of x cubed. So essentially just multiplying by 1. So now what that does is it makes it so that I have 4 of these down here, and so that when I combine them, it's the same as saying the 4th root of x to the 4th. And now it's going to cancel out that 4 out in front. So that's what I want to do, is I want to multiply by however many more 4th roots of x that it would take to cancel out. So that leaves me on the top with 3 times the 4th root of x cubed. And that bottom now just becomes x. So we have 3 times the 4th root of x cubed on the top, and we just have x on the bottom, and that's our final answer. So let's go ahead and turn the page, and we'll just talk a little bit about what's remaining in the guided notes here. The next 2 pages